What's happening, dogs? Mr. Allen here with some simplifying of rational expressions, and we'll be talking domain restrictions here for each one of these examples. So in order to simplify rational expressions, they have to be in factored form. Well, this one's already in factored form. My x plus 4 going to cancel along with that x plus 4. Nothing else can cancel. So my final answer here is going to be that x minus 7 divided by the 3 times the 2x plus 1. Now, you could distribute that 3 back in. That's fine. You don't have to. If it's multiple choice, they may have it distributed back in. I don't know. All right, but that would be our final answer here, but we also need our domain restrictions. I left a little spot there, so don't forget, because it's easy to forget. Now, the domain restrictions are caused when we divide by 0. Since we're dealing with fractions here, the no-no, right, that we're talking about is you can't divide by 0. If you're talking square roots, can't have those negative numbers because you can't square root negatives unless you're dealing with imaginaries. It's a whole other thing. So what's going to make my denominator 0? In the original, okay? It's the original that we got to deal with here to list all my domain restrictions. Well, this one right here, pretty easy. It's x cannot equal negative 4. If I plug negative 4 in, I'd have negative 4 plus 4 is 0. Anything times 0 is 0. My denominator is now 0. I'm dividing by 0. Can't divide by 0, okay? Cannot divide by 0. If I held out $5 and just left it, that's not dividing by 0 because you know somebody's going to pick up that $5. You can't just leave $5 on the ground. Somebody's going to get it. That's divided by 1. So it's impossible. All right. But what's going to make the 2x plus 1 equal to 0? You might be able to do this one in your head, but you may want to do a little side math here to get this domain restriction. Set the 2x plus 1 equal to 0 to find out what makes it 0, and then I can use that to tell me what I'm not allowed to have for my x values. So if I subtract 1, I get 2x equals negative 1. If I divide by 2, I get x equals negative 1 half. So my other value here is negative 1 half for my domain restriction. What about this 3 out here? That doesn't have an x, so it doesn't matter what I put there. I can't put anything there, so that doesn't add to the domain restrictions. If that was a 3x, then 0 would also be included in these domain restrictions because plugging in 0 for x would make the whole thing 0, okay? So these two right here are my domain restrictions for this particular one. If you have a lead coefficient, you got to do a little more work. You could probably do it in your head. Subtract 1, divide by 2, we get negative 1 half, but it is often helpful to do a little bit of side math just to make sure. Domain restrictions, answer. If they only ask for an answer, this is it right here. If they ask for the domain restrictions as well, you're going to need those too. Cool? Enough on that one. Let's go to the next one. Well, now, oh my goodness, I'm not in factored form. I have to factor. My favorite F word, man. And I love it with rationals because you get to factor multiple times in every single problem. And when you're multiplying, oh my goodness, you're going to be factoring like 4 times, bro. All right, numerator, what multiplies to 5 and adds to negative 6. So we're multiplying to this, adding to that. That's going to be, let's see here, 5 and 1, negative for both, negative 5, negative 1. Love it. Down here, it's a difference of 2 squares. So that's going to be x minus 1, x plus 1. These two are going to cancel. My final answer is going to be x minus 5 over x plus 1. But yes, we do need to have our domain restrictions as well. Okay? So what is x not allowed to equal? I always do it when I'm looking here. I got positive 1 for this factor, negative 1 for this factor, 1, negative 1. That's it for my domain restrictions. You may want to just jump right down to the domain restrictions once you get it into factored form so that you don't forget about both of them. It's what's in the entire original problem. Okay, so keep that in mind here when you're listing your domain restrictions, but that's my final simplified form once I've canceled my factors. Okay, it is tempting, I know, to be like, can I just cancel those x squareds? No. If there's addition or subtraction attached to stuff, it's not freely cancelable. Okay, it's once I get into factored form because between these parentheses here is multiplication. So we can do that here in a division problem. The addition and subtraction is contained within the parentheses. So I can cancel full factors or nothing at all. Okay, next one here. All right, we got a factor. Okay, we got a factor. So let's see here. I'm going to go with neon yellow. All right. My numerator, we always freak out when we see these. It's actually like the first type of factor we learned. GCF. What can I take out of 4 and 16? It's 4. So I can take out a 4, and I'm left with x minus 4 when I divide by 4 on both of these. Then down here, it's the same method there. What multiplies to negative 20 adds to 1 in this case, which is going to be x plus 5, x minus 4. I can get my domain restrictions right now. Let's just go ahead and do that. X cannot equal negative 5. Positive 4 is going to make that factor 0, right? It's whatever makes my denominator 0 is a domain restriction because I'm not allowed to divide by 0. Now, what's going to cancel here? Anything. The x minus 4s are gone, leaving me with, in the numerator, I've got 4. And over here, I have x plus 5. Excellent. There's my final answer. Now, question. What if everything was gone from the numerator? Because that can happen. What if this 4 canceled with a 4 that was down here? Would it just be x plus 5 as my answer? No. If everything gets removed in my numerator, I got to throw a 1 up in my numerator. I guarantee you're going to see one of those. All right, so if everything gets canceled out from my numerator, but I have stuff left in my denominator, it's 1 over whatever that stuff is. So keep that in mind as well. I know I'm throwing a bit at you guys right now, but you guys are straight G's, okay? You can handle this thing. All right, last one here. I'm going to go back to blue. All right, oh boy. A lead coefficient. Really? Really? Yes, really. I wrote the problem. Okay. So I'm going to go 2 and 7 and 5. They're all prime numbers. So there's really only like 2 possibilities here. This is prime real estate for some guess and check here, guys. All right. So I know one of my factors has to be 2x to start. The other one has to be x. That's the only way I'm going to get 2x squared. Well, what numbers multiply to 5? 1 and 5. If I put a 5 right here, I'd have 2x times 5. That's 10x. Ain't no way that's going to add up to 7x, right? But if I put a positive 5 here and a positive 1 here, 2x and 1 gives me 2x. 5 and x gives me 5x. What's 2x plus 5x? It's 7x. Boom. We guessed, we checked, we're Gucci, all right? If you can't handle the guess and check, it's totally fine. I get it. Takes a little bit of thinking and all these different things that are going on in your head. Sometimes it's just easier to do rainbow method or any of those other tricks of the trade. But guess and check is pretty dope right there, okay? Also, another pro tip with the guess and check, everything was positive here, so I already knew everything was going to be positive. That's kind of nice. Last one here, what can I take out? I think I could take out a 2 on this one, so we get 2, and I'm left with 2x plus 5. How convenient. All right, so what is my domain restriction going to be? I only have 1 here because I only have 1 x. This guy doesn't have an x, so that means that x cannot equal, let's see if we can do this in our head. I'd subtract 5, divide by 2, so negative 5 over 2. Beautiful. If you needed to, you could always do a little bit of side math, right? We'd have 2x plus 5 equals 0. Subtract 5, I get 2x equals negative 5, divide by 2. Boom. There is my domain restriction, okay? So you can always set each factor equal to 0 to find your domain restriction, especially if it's a 2-step, solving situation. Okay, last thing, cancel. I'm left with x plus 1 over 2. Beautiful. Nice. That's about it, man. Let me just circle that bad boy right there, and we are ready to rock and roll out of here, man. All right, simplifying rational expressions. Hopefully that helps there, guys, because we're going to be multiplying them, dividing them, adding, subtracting, all sorts of stuff. But the base here, right, this can be thrown into any one of those. So you got to start with some of the basics, and hopefully this all helps, all right? Have a great day, guys. Keep watching the videos. Hit that like and subscribe button. That's always a good thing, Gets more people to see the dope math. You know what I'm saying? See you later.